Yo, what's up guys? I'm going to teach you how to do some bearings for trigonometry. Okay, and we're going to look at something called true bearings, which basically just means when you're at a particular position from north, okay, from the north direction, how many degrees or at what angle do we need to turn to go to where you are now? Okay, so it's just a way to measure direction. And like I said, this is something called true bearing, and we're going to calculate it from the north, okay, as our starting point. So if I was to put this into practice, it says, sketch the diagram when M is on a bearing of 315 degrees from P. This degree sign should be like up here, by the way. When you do these, just find where it says from P. So just find the starting point. Let's call it P. And draw a north facing line. And 315 degrees. I want you to think back to these quadrants, these four quadrants. And recognize, okay, if this is 0 degrees, and this is 90 degrees, and this is 180 degrees, and back to 360, 315 degrees is like somewhere up here, right? It's in that fourth quadrant. So we know that it should be somewhere there, right? And we can fill out this is 315 degrees. Okay, and that's it. That's how we draw the diagram for this type of bearing question. Okay, let's try question 2. And it says x is on a bearing of 30 degrees from y. Again, just find where it says from y. And 30 degrees, now that is not, that is less than 90 degrees, right? So that's just somewhere like here. 30 degrees. And yeah, that's the basic idea. Okay, so we're going to use that and try to sketch these different situations, okay, and we're going to apply some trigonometry to it. Okay, so this is what we know. So in question 3, we have a plane flies 100 kilometers due east, then 125 kilometers due north. Find its bearing from its starting point to the nearest degree. Okay, so the first thing to do is to draw the diagram. So we've got a plane flying 100 kilometers due east. 100 kilometers due east, and then 125 due north. Okay, and it just goes straight up. And since it went from east to north, that means this should just be 90 degrees. And the question is, find its bearing from its starting point. Okay, so this is my starting point. From north to where you are now. Okay, that angle there, theta. Okay, so that's what the question is asking for. That's the bearing. And we have a right angle triangle now, so we can just use some basic right angle trig. It's going to involve one of these two angles, right? Now, if you look at this angle, that we can just say that's 90 minus theta, right? Since this whole thing is 90 degrees. But I always prefer to go for this one here, where this one is just equal to theta, nice and clean. And just understanding basic geometry from alternate angles, which you all should know as well. Yeah, I always find this one a little bit neater, the alternate angles. But yeah, both ways should work. So here we have opposite and adjacent. So let's say tan theta is equal to 100 over 125. Theta is tan inverse 100 over 125 degrees. Okay, so whatever this degree is. Okay, so let's put it into our calculator. And we should get theta is equal to, I'm going to say roughly 39 degrees to the nearest degree. So therefore, bearing is 0.39 degrees. Okay, so hopefully that was Hopefully that made sense. Okay, let's try a couple more. So in question 4, we have a ship sails on a bearing of 140 degrees from Sydney for 250 kilometers. Again, let's just draw the diagram first of all. And it says from Sydney. So from Sydney on a bearing of 140 degrees. So that's north. 140 degrees is greater than 90, but less than 180. Right? So this was for 250 kilometers. And the question is, how far east of Sydney is the ship now? Okay, so basically Sydney is here, and now I'm here. And the question is, how far east are you? Well, this is the horizontal distance, and this is how far east we are. Okay, and to finish the triangle off, we can just continue this down, because this is a north, just a very vertical line, and vertical and east, so we got 90 degrees. And the question is basically, this is x. How far east are you? Okay, again, oh, I didn't label this angle. That's 140 degrees there. Which means inside, since it's 140 degrees and a straight line, inside here, that means that's just 40 degrees, right? Okay, so what do we have in this triangle? We have opposite and hypotenuse. So let's say sine 40 degrees is equal to opposite over hypotenuse. Okay, and then we can calculate this, and we can say 161 kilometers to the nearest kilometer. Okay? Cool, so that's the answer for question 4. Let's try one more before we wrap up this video. So a plane flies north from town for 400 kilometers, then turns and flies east for 300 kilometers. What is the bearing? Okay, so from town, we're going north, right? So this is town. We're going north for 400 kilometers. And then you turn and fly east for 300 kilometers. What is the bearing from the town? Oh, very easy question. So from the town, this is already north. And this is where you are now. So just what is this angle? We have opposite and adjacent, so let's use tan. Tan theta is equal to 300 over 400. Theta equals to tan inverse 3/4, which gives us 36 degrees and 52 minutes. So we can say, therefore, they want the nearest degree. Okay, so the bearing is 0.37 degrees. Cool, so that's basically how we do bearings. Okay, so it's just basically drawing up a diagram and then using our basic trigonometry. Okay, and that's it for this one. I'll catch you in the next video.